Today we begin Chapter 12. Chapter 12 is going to start talking about sample space and probability. So we're going to need to know some vocab words. So it starts out with probability experiment. Now that really refers to an action or trial that has varying results. Anything you do that could have more than one result is a probability experiment. Think of flipping a coin, spinning a spinner, or rolling a dice. The outcome is the possible result of an experiment. So for example, if you roll a die, there's 6 possible outcomes. You could get a 1, a 2, a 3, a 4, or a 5, or a 6 in that roll. So you have varying outcomes that are possible. When you flip a coin, you have 2 possible outcomes. You can either get a heads or a tails. So an event is an outcome or a collection of outcomes. So if you want, for example, to roll an even number, that would be the probability of that event occurring. If you want to roll an odd number, that's an event. If you want to roll a 2, that's the event you want. And the last thing is your sample space. And this is the set of all possible outcomes. So just like we listed all the outcomes of rolling a die up here, that we can get numbers 1 through 6, the sample space would be the set of those numbers. So when we ask you probability questions, we could be asking you, for example, 2 things. So here, for example, notice that they're asking or saying that you flip a coin 2 times. So we have flip 1, the first flip, and we have flip 2. So there's 2 things that are happening here. And it says how many possible outcomes are in the sample space. Well, how many possible outcomes do you have of your 2 flips? And then it asks you to list them. So first it's just how many, and the second is to list them. So for how many, it's super easy. You take each event and you say, okay, how many outcomes are in each event? When I flip the coin the first time, how many possible outcomes are there? Well, there's 2 outcomes because there's a heads or a tails. When I flip it the second time, how many possible outcomes do I have? 2 again, heads and tails. So how many possible outcomes is the product of those? So 2 times 2 is 4. So how many possible outcomes? There's 4. Listing them is a little different. The main way we list is when there's 2 events is we try to do a little table. And we do, okay, let's say flip 1 here and flip 2 here. So we can get a heads or a tails on flip 1, or we can get a heads or a tails in flip 2. And then we can kind of just put those combinations. I'll start with like this one first. So heads, head. Let me kind of do this right. So I'll do heads, tails, then I'll do tails, heads, and I'll do tails, tails. And so when you ask to list, this is your combination. And so those are the 4 possible outcomes listed out. You could get a heads first and then a heads second, a tails first and a heads second, a heads first and a tails second, or a tails first and a tails second. And so that's how we would answer these types of questions. So again, notice here, you flip a coin and you roll a die. A number cube and a die are the same. How many possible outcomes? Well, again, there's 2 events. There's 2 possible outcomes to flipping a coin and 6 possible outcomes to rolling a dice. So there's 12 total possible outcomes in the sample space. Now, if you want me to list them, right, or if I want you to list them, then you're going to have to do the main thing. Like I said, I kind of recommend doing the table. So there's 1, 2, 3, 4, 5, 6. Sorry, it's kind of not really perfect, but whatever. So I could get a heads and a 1, a heads and a 2, a heads and a 3, heads 4, heads 5, and heads 6, tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. And those are the list of the possible outcomes. You don't have to rewrite them for me. You can do them that way. Other methods for writing these are sometimes these little tree diagrams. Like we could say, okay, here's event 1, right? You can get a heads or a tail on the coin. Event 2 is the dice. And so you could get a 1, a 2, a 3, a 4, a 5, or a 6. And again, you would do the exact same thing for a tails. Again, you could get a 1, a 2, a 3, a 4, a 5, and a 6. I don't particularly like this method unless I have 3 or more events. Then I have no choice but to use it. So then we talk about what is the probability of an event occurring. Well, again, probability of an event occurring is the chance or likelihood that it's going to happen. It's always going to be between 0 and 1. Something that has a probability of 0 means it's never going to happen. It is impossible. An example of this is rolling a 7 on a die, right? You're like, wait, how is that possible, right? You're going to create this thing. You're going to say, okay, if I have a dice and there's 6 possible outcomes, right? 1, 2, 3, 4, 5, 6. What is the probability of rolling a 7? 0 out of 6, which is 0. You can write a probability as a fraction, a decimal, or a percent. So what's something that is certain? Well, maybe I'm wanting to know what is the probability of rolling a number 1 through 6 on a die. Well, again, there's 6 outcomes, and 1 through 6 is all 6 of those. So 6 over 6 is 1, or 100%. And so again, that's a certain outcome. No matter what you do, you're going to get the outcome you want. The event you want to occur is going to happen. Everything else falls in the middle. Okay, so something that has a 0.5 or a 50% probability is equally likely or unlikely to happen. Anything on the left side of this is unlikely. Anything to the right side is likely. And obviously, the closer you get to 1, the more likely it is. The closer you get to 0, the less likely or the more unlikely something is. Oh, and also, if you want to write the probability of an event A occurring, you just say the probability of A in parentheses. So how do we find our theoretical probability? And we're going to talk about 2 kinds of probability today, theoretical and experimental. But for right now, theoretical is the probability of the event you want happening in theory, right? So basically you put the number of favorable outcomes. By this, we mean what we want to happen, okay? Over the total number of outcomes, meaning all that could happen, if that makes kind of sense to you. So again, if I say, what's the probability of rolling a 3, right? Let me do this right. So I'm rolling a dice, and I'm going to do the probability of getting a 3. Well, on a dice, there's 6 possible numbers I could get, so that's my denominator, and there's 1 3. So I know the probability is 1 over 6, or whatever that converts to as a decimal or a percent. If I say, what is the probability of getting an odd number on a dice? Well, numbers, here's my outcomes, right? 1, 3, and 5 are all odd. So there's 3 possibilities of getting an odd number out of 6 total outcomes. So that's a half or 0.5 or 50%. That's my probability of getting an odd number. So again, we go back here, and now we're going to find some probabilities. So you toss a coin and you roll a number cube. What is the probability that the coin shows heads and the number cube shows 5? So again, we got to know, first of all, if I toss a coin, I have 2 outcomes. If I roll a dice, I have 6 possible outcomes. And so there are 12 total possible outcomes in this sample space. So I know my probability of getting a heads and a 5 is going to be some number out of 12 possible outcomes. Now, how do I do this? I'm going to have to do that chart that I did before. I'm going to have to go back to that other thing. And if you remember, you did your little chart, and it was heads 1, heads 2, heads 3, heads 4, heads 5, and heads 6. And then again, these were all tails, right? 1 through 6. So notice there's only 1 out of the 12 things that was a heads and 5. So my probability is 1 out of 12. As a decimal, this is 0.083, and as a percent, it's 8.3%. Remember, to convert from a decimal to percent, you just move the decimal point 2 places to the right. So then in B, I'm going to look at the table here that they gave me, they provided me, and they said, what is the probability that a student chooses a t-shirt with a gold emblem? Now, if you look at the table, it's telling you how many of each thing there are. So the first thing I'm going to have to do is, well, how many options do I have here? For gold emblem, there's 16 t-shirts that have a gold emblem, and there's 14 t-shirts that have a silver emblem. There's a total of 30 t-shirts. So what is the probability that a student will choose a t-shirt of any color with a gold emblem? Well, 16 out of 30. And again, you can simplify that. You might want to, break it in half. That's 8 out of 15. And then again, convert that to a fraction. It's already a fraction, rather, a decimal or a percent. As a decimal, it's 0.533. And as a percent, it's 53.3%. So sometimes we come across these problems that say probability of the complement of an event. So, for example, an event occurring is what you want to happen. The complement is what you do not want to happen. So again, let's go back to the dice because that's an easy one, right? So if I say, what is the probability of rolling a 3? You know that probability is 1/6, right? It's 1 out of 6. Well, what is the probability of not getting a 3? So you think about that and you're like, well, there's 1, 2, 3, 4, 5, 6. The probability of not getting a 3 is 5 out of 6. And so we actually learned that there's a formula or a little equation you can write to solve for something not happening. And what it is if you want the probability of something not happening, of not getting a 3, it's 1 minus the probability of the event actually happening. So the probability of a 3 happening is 1/6. So 1 minus 1/6 is 5/6. And that's the probability of it not happening, or the complement. So you can either solve it the long way, which is just go back and count and figure out everything but 3, or you can do a subtraction problem. So if it tells you that the probability of an event occurring is 0.45 or 45%, right? The probability of the event not happening is 1 minus 0.45, which is 0.55, which is 55%. I also like to do it as percents. It's 100% minus 45%, which equals 55%. Either way works. And then the last type of question that we're going to get to are geometric probabilities, where we give you these geometry problems, area problems, and we say, hey, here's this probability, here's a dartboard. What is the probability that you're going to land in a certain space? And so again, if you think about it, it's what is the area of the space you want to land in versus the entire area of the board. So your sample space or possible outcomes is the area of the entire board. So again, let's say it might work with lengths, it might work with areas, or it might work with volume. Okay, so it's not always area. So again, you throw a dartboard at the board shown. Your dart is equally likely to hit any point inside the square board. Are you more likely to get 10 points or 0 points? So first of all, 10 points means it landed in the red section. So I remember this problem here. My students sometimes thought that the 3 inches meant that the radius here was 1, 1, and 1, which added up to 3. Other students interpreted it to mean that each section is 3 units long. I did it that way. It doesn't really matter whether you do the 1 or the 3, as long as you're consistent, but I'm going to solve it assuming it meant 3 for each piece. Okay? So the first thing I want to do is I want to figure out the area of the whole board. Okay? So the area of the board is going to equal the length times the width. Well, if the radius here is 9, then the entire side is 18. So, and it's a square board, it tells me somewhere here. So I know it's 18 by 18, which is 324 units squared. So that's my total possible outcome, okay? So I know that my probability is going to have a denominator of 324, okay? So then I come over here and I'm like, okay, what is the area of the circle? Because that's the 10 points, the pink circle, right? Because that's the 10 points they mention. So I know that the area of a circle is pi r squared, and if the radius of this little circle is 3, then I know it's going to be 9 pi. So that's that. So let me convert that to a decimal. So I'm going to round that to 28.3 units squared. And then I'm going to find the area of the blue. Now notice the blue is basically, if I think about it, it's the whole square minus this big yellow circle. That's going to leave me with the little blue piece. So again, now I'm going to have to calculate the area of the large circle. So this was the red circle. This is the area of the large circle. And so again, it's pi r squared, but in this case it's 369. So it's going to be 9 squared pi, or 81 pi. And again, let me convert that. And it's 254.5 units squared. So the area of the blue, the little blue thing, is going to be the entire 324 minus the area of the yellow, 254.5, which is going to be 69.5 units squared. Okay, so now I've got everything I need for my probability. So the probability of getting 10 points, which is the probability of the landing in the red circle, is 28.3. That's the area of the red circle over 324, which is the entire square. So that equals 0.087 or 8.7%. So the probability of 10 points is that. The probability of 0 points is, again, it's going to be the area of the blue, which we calculated was 69.5 over 324, which is 0.215 or approximately 21.5%. So which one is more likely to occur? The 0. You're more likely to get 0 points than you are to get 10 points because 0 makes up more of the square or the board than the red. Now, all this is great, but these are all theoretical. This is in a perfect world. This is what's going to happen. However, sometimes you actually run an experiment or a trial, and your outcomes do not match what theoretically is supposed to happen. So experimental probabilities are the probability based on a particular trial of an experiment. The number of trials is the number of times the experiment is performed, and success is, of course, each trial in which what you are looking for, the favorable outcome, actually occurred. So experimental probability is the number of successes over the number of trials. So, for example, let's say I was flipping a coin and I wanted to get heads. And let's say I flipped the coin 20 times. And out of the 20 times, I got heads, let's say 14 times, and I got tails 6 times. So normally, you know that the probability of getting a heads in a coin is 1 out of 2. This is theoretical, right? I can only have 2 outcomes, and heads is one of them. But in my experiment, where I actually flipped it, out of 20 times, I actually got heads 14 times. So my experimental probability was 0.7 or 70%. So this is my experimental probability of getting heads. Now, again, it's very different than my theoretical, because theoretically it should have only happened 50% of the time. But in my practice, it didn't. It happened more. And so that happens a lot in experimental probabilities. I will tell you that the more you do something, the more likely your experimental probability will get closer and closer to your theoretical. If I had flipped the coin 1,000 times, I'd be closer to 50% than with 20 attempts. If I flipped it 1,000,000 times, I would be much closer to the theoretical probability. So again, here we get a question where it asks us, it says, here you have a spinner. Each area has this, each color has the same area. So this is the same size as this one, and as this one. And so it says the spinner was spun 20 times. So notice an experiment was run here. Okay? And in the experiment, they had certain outcomes. The table shows you the outcomes. When they did the experiment, they did a red 5 times, a green 9 times, a blue 3 times, and a yellow 3 times. Notice that that adds up to 20. So it says, for which color is the experimental probability of landing on a color the same as the theoretical? Well, let's talk about theoretical first. And the theoretical, actually, let me put it over here. The theoretical probability of getting a red is going to be 1 out of 4, or 0.25, or 25%. The theoretical of getting a green is going to be the same thing. So notice that the theoretical probability of landing on any of these colors is each going to be 25%. Now in practice, you got red 5 out of 20 times, which is 1/4, which is 25%. You got green 9 out of 20 times, which is 0.45, or 45%. You got blue 3 out of 20 times, which is 0.15, or 15%, and yellow is also 15%. So which one is the same as the theoretical? Red. Red occurred 25% of the time, which is what we would have expected in the theoretical. So the answer for this question is red.